Do you feel the vibes?
Okay, so let's start talking about probabilities. So the probability of something happening, right? Okay, the probability of something happening, we call that the probability of an event. That's the number of favorable outcomes. So for example, the probability of you winning the lottery, okay? It's the number of ways that you can win the lottery divided by all of the possibilities out there, okay? Or the probability of you rolling a 2, right? When you roll like one die, right? That's like how many ways can you roll a 2? That's the number of favorable outcomes. How many, what are all the total numbers that you can roll? That is the total number of possible outcomes. Okay. So first we're going to talk about a lot of vocabulary. Now, a sample space is a list of all possible outcomes. All possible outcomes. Okay. So example, what is the sample space when you roll a die, one die? Well, you can get a 1, a 2, a 3, a 4, a 5, and a 6. It's all of the possibilities. That's the sample space. If there are n outcomes, then the probability of each is equally likely, and it's 1 over n. Okay? So the probability of each equally likely outcome is 1 over n. So for example, what is the probability of rolling a 4 on a die? Now you have an equal chance of rolling a 1, a 2, a 3, a 4, or 5, or a 6. There are 6 possibilities. The probability of rolling a 4 is 1 out of those 6. The probability of an outcome is always going to be between 0 and 1, because either something does not happen or it happens and then it's a 1. Okay? All right. So like, for example, you never have like a 200% chance of something happening, right? No, like it's a 100% chance or a 0% chance. Okay? All right. So let's take a look at this. A die is rolled. What is the probability of each of these things? And you want to write it as a ratio. So what is the probability of rolling a 2 or a 3? Now, okay, so let's go back to that formula in the green, right? The number of favorable outcomes over the total possible outcomes. So total possible, you have 6 possibilities, right? Of those 6, how many situations are okay for you? 2. So that's 2 over 6, which of course we always simplify to 1/3. Okay. Okay. What is the probability of rolling an odd number? Well, either a 1, a 3, or a 5, right? So 3 out of the 6, or 1/2. What is the probability of rolling a 5 then? 1 out of 6. Okay. Not rolling a 5. So your favorable outcomes are getting a 1, 2, 3, or a 6, right? Or a 4, right? So basically 5 favorable ones, so 5 out of 6, right? So do you see how, like, for these, it's not a formula. You're reasoning things out, okay? All right. Now, the event of rolling a 5 and not rolling a 5 are complements, okay? The possibility of rolling a 5 is 1 out of 5. The possibility of rolling a 5 is 1 out of 6. The possibility of not rolling a 5 is 5 out of 6. They're complements because together those add up to 1. Okay? So let's talk about notation. When I have P parentheses 5, that is the probability of getting a 5. P not 5 is the probability of not getting a 5. Okay, yeah. It's 1 because it's a probability is a number. The probability is always 0 to 1. So what is the probability that you'll either get a 5 or not get a 5? 100%. Right? The P is word. What is the probability of getting a 5? The sum of probabilities for any two complementary events is always 1. Okay. Let's go to the... But yes, these are always on standardized tests. Correct. Lots of marbles and socks on tests. Yes. Yeah. All right. So 1 second. I just wanna. Okay. Okay. So a bag contains. Okay. A bag contains 3 red marbles, 6 blue, 5 yellow. 1 marble is chosen at random. Find each probability. Write them as a ratio, a decimal, and a percent. Okay, so first of all, I have 3 red, 6 blue, 5 yellow for a total of 14 total. That is your sample space, 14. Okay, so getting a blue, there are 6 blue. So there are 6 favorable outcomes. So that's going to be 6 out of 14, which is 3/7. If you want to convert it to decimal, this will be about 0.43. And that will be 43%, right? Because we want 2 decimal place and the nearest percent. Okay, so red or yellow. There are 3 red, 5 yellow. So 8 of the marbles are okay for us to choose, right? So that'll be 8 out of 14, 4/7. And I know you can all put them in your calculators. You get 0.57, which is 57%. Not red. So I don't want any red. That means the 6 blue are okay. The 5 yellow are okay. So 11 marbles are okay, are favorable. So 11 out of 14, right? This will be about 0.79, which is 79%. Neither blue nor red, so what do I want? Yellow, which is 5/14. And that's about 0.36, which is 36%. Okay. Let's talk about a tree diagram. So it's easy to visualize when it's just like marbles or rolling a whatever, right? But sometimes when it's complicated, like it's really hard to see all of the possibilities and to sort through them, right? So that is where a tree diagram comes in, because it literally helps you visualize all of the possibilities. Now, in a tree diagram, the last column shows all the possible outcomes. So we're looking for the last column. Okay, a little thing here. It could also be done like, sideways, flipped over, and then it'll be like, like the last row, but it's fine. Okay, draw a tree diagram. Oh, you know what? Let me just do an example before I get to that. So suppose I want to do a tree diagram for tossing a coin. For tossing a coin 2 times. Right? The first time you toss the coin, what are the possibilities? Heads or tails? Okay, so suppose you got heads the first time, and now you toss the coin again. Now you've got heads or tails, right? And then you toss it again. Suppose if you got tails, you toss it again and you get heads or tails. Okay, so How many do you have in your last column? 4. So those are all of the possibilities. So that's how many total possibilities there are. You could have gotten heads, 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 tails, tails, heads, tails, tails. So 4 possibilities. That's how a tree diagram works. All right? Okay. So let's take a look at this. Draw a tree diagram for the different options of ice cream. You can choose between a sugar cone or a waffle cone. You can, and then once you choose the cone, you can choose either a scoop of vanilla or chocolate, and then you can either choose sprinkles or nuts for a topping. So the first was in the blue, right? So we're either going to get a sugar cone or a waffle cone. Once I choose that, now I have another level of choices. I'm either going to get vanilla or chocolate, and then I'm either going to get sprinkles or nuts. We already used S, so let me do SP or N, SP or N. Okay? So how many total possibilities? 2, 4, 6, 8. Okay? All right. And then if you wanted to list all of the different possibilities, you would basically like go down the tree, right? So it would be sugar, vanilla with sprinkles, or you could get, let's say, waffle, chocolate with sprinkles or whatever. Okay? All of those possibilities. Okay. Fundamental counting principle. Yay. All right. The number of possible outcomes in a sample or in a sample space can be found by multiplying the number of possible outcomes for each event. So for example, look here. This was cool. Okay, I had 2 choices, 2 choices, 2 choices. I wrote my cute little diagram, 8 of them. Okay, but what if I have, like 5 choices of bread, okay, 17 choices of what goes in there, and then 12 choices of like condiments. I'm not gonna sit there and like draw every single one. That is just silly, right? But I can multiply them. So for example, at the first stage in the blue, there were 2 possible choices. With the purple, there were 2 possible choices. With the red, there were 2 possible choices. 2 times 2 times 2 would have also given us 8. Okay? That's the fundamental counting principle. So Kathy needs to make a 4-digit password for his login on a website. Okay, 4 digits. 1, 2, 3, 4. Draw them out. The password can include any digit from 0 to 9, but the digits may not repeat. How many possible passwords are there? So in the Tell me.
Because
No, what did you get?
I got 5,040.
That's right.
Yeah, because she can have 10 digits, or you can have 10 digits the first time, but then only 9 the second one, then 8 the third, and then 7 the fourth. Yeah, so just multiply those numbers together. What if they could repeat?
They can. Well, you tell me.
What if we put that in the
Huh?
I don't understand.
He said exactly. Don't listen to anybody. You said exactly the same words that I would have said. So now I'm going to say the same words that you said, but with my teacher voice and pausing at appropriate places for people to process. Ready? Let's do this. I'm literally going to use the exact same words because those were the words I would have used. Okay. So for the first possibility, you have 10 possibilities. For the first digit, you have 10 possibilities. Right? Is that 10 from 0 to 9?
Yeah.
Okay. Now, you used one. So that's out. How many do you have left for the second one?
9.
Now you used another one. That's out. How many do you have for the next one?
8.
And then you multiply them all out. Okay? Yes.
So why did we write them in digits?
For the first slot, you have 10 possibilities. In the second slot, you now have 8 possibilities. For your third digit, you now have 8 and whatever. So then you multiply them out. The answer is 5,040. Okay? Now, if you were allowed repeats, okay, you're going to use a 4-digit password. A 4-digit password. For the first one, you have 10 numbers to choose from. Second one, you have another 10 to choose from. 10 and 10. So it would be 10,000. Right? 10 to the 4. Okay? So find the number of possible outcomes for each situation. Okay. So here's an answer sheet, right? You can randomly guess answers. So suppose, I don't know, you're like protesting and you're like, I'm not going to read the questions because I don't believe we should have a test today. And I'm just going to, put down answers. Fine. Whatever. Okay. So how many possibilities do you have? Okay. So how many total answers are there? 6, 7, 8, 9, 10. How many possibilities do you have for the first one? 4. Then 4. Then 4. Right? Oh, absolutely. Nobody does what I'm doing. Okay? We're just doing it the first time so people can visualize. Okay? So that would mean you have 4 to the power of 6 times 2 to the power of 4. 65,536.
Is that 16 to the 4?
Possibilities. No. What? 2 to the power of 4.
No, but together. 4 to the power of 6
Oh.
is 16 to the 3.
4 to the power of 6?
What is 4 to the power of 6?
I don't know. It's a really big number. Okay. It's not. It's. I think I know what you're doing, and it would be like 2 to the power of 2 to the 6. So it would be 2 to the power of like 16 or something.
So it's 2 to the 20.
16 total. Okay, so a die is rolled 4 times. So take a look. You roll 1 time, you get 6 possibilities. Another one, 6 possibilities, and so on. So 6 to the 4, 1,296 possibilities. Total possibilities, right? So what do I mean by this? That means, one possibility is you got a 3, a 4, a 2, a 2. Okay? Like, then there are 1,296 possibilities. Okay?
Wait, so then what's the probability of getting
Of getting, let's say,
like
a
say,
3.
would it be 4 over that? Because it's 4.
No, you're only going to get it. Well, yes. So we're going to do all this. Okay. So the number of different class rings that can be created. Okay. So look, you've got this many different metals to choose from, right? Like platinum, gold, silver, blah, 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 blah. This many finishes, this many stone colors. So you literally just multiply all of those. 10 times 2, 10 times 2. Times 12 times 5 times 20, another 20 times 2. That'll be a total of 960,000 possibilities. Lots of possibilities. Okay, and we're actually going to stop here today.